The first spacecraft for the world's next big mission to Mars is almost complete. At Thales Space in France, everyone is working to the launch deadline early next year. Once ExoMars 2016 arrives at Mars, it will release a capsule aerodynamically shaped for a controlled entry into the Martian atmosphere and containing a robotic lander. The rest of the spacecraft will go into orbit around Mars. The ExoMars 2016 orbiter, a joint mission between ESA and Roscosmos, will send back crucial information about the atmosphere, sniffing it for methane and clues for the possible presence of life. The lander's findings will help future lander missions. Then, in 2018, the second part of the ExoMars mission will be underway, including a rover with a drill.
ExoMars 2018 is really opening a new chapter in Mars exploration. For the first time, we will address the third dimension, which is depth. All missions up to now have only dug the top 5 centimeters of the surface, and we will go down to 2 meters. This is very important because it is in the subsurface and at depth that we have the best chance of finding evidence for the possible past presence of life on Mars.
The search for life on Mars involves a team from ESA and Roscosmos, but placing a robotic lander on the planet's surface, as many missions have discovered, is not easy. The chosen site for the rover will be both safe for landing and scientifically interesting.
We see here the prototype of the rover going down the ramps. This is more or less how it will happen in real on Mars. This mast is fixed in the ExoMars rover. It will be a deployable mast. On the top there will be navigation cameras used for the autonomous navigation of the machine, and also panoramic cameras that are scientific instruments, wide-angle cameras and high-resolution cameras, and they will be used for the localization of the targets on Mars where we want to go to make our drilling and our investigation.
The rover will study rocks and look for places below the surface where water-related minerals were once deposited. It will then drill down to 2 meters, searching for traces of organic molecules that could provide clues to the past presence of organisms.
The microbes themselves would be too small to see. Their size is in the order of 1 to a few microns. So you would need a big fat microscope to be able to see them, something we don't have on our missions. But colonies of organisms can affect the deposition of rocks, and that we will be able to see. The other type of biosignature is organic molecules. And here you have to think of them as the Lego bricks of cells.
The ExoMars rover could also spot any present-day life on Mars, hidden beneath the surface away from harmful radiation. Until then, we can only wonder if there is life on Mars or not.
It's, of course, $100 million question. I'm convinced that there has been life on Mars.
By the end of the decade, ExoMars could know for sure.